For 60 years, we have pointed our ears at the sky and listened to the static. We have built cathedral-sized dishes of steel and wire, aimed them at the densest clusters of stars, and waited. We are waiting for a pattern, a sequence of prime numbers, a greeting, a steady, rhythmic pulse that proves we are not alone in the infinite dark. We expect this because it is what we would do. We assume that an advanced civilization is a benevolent teacher, standing on the cosmic porch with a lantern waving us down. We assume they want to be found, but this expectation is built on a flaw in human psychology. It is an anthropocentric arrogance that suggests the universe operates on our timeline and our etiquette. The laws of physics and the brutal history of biological evolution on Earth suggest a much darker reality. The universe is not a classroom, it is a forest. And in a dark forest, you do not light a fire unless you have to. You do not scream unless you are in pain. What if we have been looking for the wrong thing entirely? What if first contact doesn't come as a peaceful, repetitive message, but as a scream? The uncomfortable truth is that intelligent life likely won't be detected because it is trying to communicate. It will be detected because it made a mistake. We aren't looking for a civilization in its prime. We are looking for a car crash. To understand why we might have missed the signs, we have to understand a cognitive bias known as the streetlight effect. There is an old observational joke about a man searching for his lost keys late at night in a parking lot. He is on his hands and knees, scouring the pavement directly under a single bright streetlight. A passerby stops and asks, "Is this where you dropped them?" The man looks up and says, "No, I dropped them over there in the dark. But the light is better here." In the search for extraterrestrial intelligence, we are that man. For decades, we have searched for signals that are easy to detect, continuous, repetitive, narrowband radio waves. We search for these because they are persistent, and our technology is designed to catch persistent things. We search for the steady state, but the universe is rarely steady. It is a place of violent, transient chaos. The most energetic events in the cosmos, supernovae, gamma ray bursts, the collision of black holes, happen in the blink of an eye. They are flashes in the dark. If we apply this logic to alien intelligence, the streetlight effect tells us that we will only find what is easiest to see against the black background of space. And the easiest thing to see is not a whispered conversation or a low energy leak. It is a massive, uncontained release of energy. We are looking for the brief, blinding moments where a civilization loses control. We are looking for the flash, not the bulb. This isn't just a pessimistic theory. It is historically proven. It is exactly how we found the very first worlds beyond our solar system. Go back to 1992. At that time, humanity had never confirmed the existence of a single planet outside our own system. We assumed that if we found them, they would be like ours, orbiting a gentle yellow star, stable and warm. We spent years looking at stars like the sun and found nothing. But we were looking under the streetlight. The first exoplanets weren't found around a sun. They were found in the most hostile, nightmare environment imaginable, orbiting a pulsar. A pulsar is the rapidly spinning corpse of a massive star. It is a city-sized ball of neutrons crushing gravity into a point of no return, sweeping a beam of intense radiation across the galaxy like a frantic lighthouse. It is a precise, terrifying cosmic clock. When astronomers Alexander Wolszczan and Dale Frail noticed tiny rhythmic irregularities in that pulse, they realized something was pulling on the dead star. They found planets where no planets should exist, bathed in deadly radiation, stripped of atmosphere, utterly dead. We didn't find those planets by looking for life. We found them by looking for an anomaly in a high-energy system. The loudest object in that sector of the sky gave up its secrets first. This creates a blueprint for the modern search for intelligence. Ignore the quiet stars. Watch the loud ones. Watch for the anomalies that physics cannot explain. This brings us to a chilling concept championed by astronomer David Kipping, known as the Eschaton hypothesis. The logic is ruthless in its efficiency. As a civilization advances, it climbs the ladder of technological capability. It learns to harness every joule of energy. A truly advanced society, one capable of spanning the stars, would not leak radio waves into space any more than a modern fiber optic cable leaks light. To leak energy is to waste it. A Type 2 or Type 3 civilization would be silent, encrypted, and thermally invisible. They would be the dark ships on the ocean. Except for one thing: entropy. Things break. The Eschaton hypothesis suggests that we will likely detect intelligence only during a moment of existential crisis, a failure of a planetary energy grid that vents excess plasma into orbit, a propulsion test that goes wrong, detonating a drive system with the power of a small star, a desperate attempt to deflect an incoming asteroid using high-powered lasers that briefly shine brighter than the local sun. These events would release a sudden, non-repeating blast of energy, a techno signature of disaster. It would look like a flash in the pan, a blip on the radar that appears once and never returns. For decades, astronomers have filtered out these transients, treating them as noise, glitches, or instrument errors. But Kipping suggests that these glitches are exactly what we should be recording. We are waiting for the moment they trip over the cord. In fact, the most haunting possibility is that we have already heard one of these screams, and we simply didn't know how to answer. On August 15th, 1977, the Big Ear Radio Telescope in Ohio was scanning the sky. It wasn't being monitored by a human at the moment. It was simply printing data onto old sheets of paper. Days later, astronomer Jerry Emmon looked at the readout and saw a sequence so strong, so distinct, and so narrow band that he circled it in red ink and wrote a single word: wow! The signal came from the direction of the constellation Sagittarius. It bore all the hallmarks of artificiality. It hit a specific frequency, 1,420 megahertz, that hydrogen, the most common element in the universe, naturally emits. Astronomers call this the water hole, a quiet band of the radio spectrum perfect for interstellar communication. The signal was 30 times louder than the background noise of space, and it lasted exactly 72 seconds. As the Earth rotated, the telescope swept across the signal, and then it swept past it. We turned our telescopes back to that spot immediately. We have listened to that specific coordinate of silence for nearly 50 years. We have used far more sensitive instruments than the Big Ear, but the signal never repeated, not once. Skeptics argue it was a passing comet surrounded by a hydrogen cloud, or a secret military satellite reflecting a transmission. But under the loud and rare framework, the wow signal is exactly what first contact should look like. A brief sweep of a radar beam not meant for us. A burst of communication from a vessel in distress. A momentary flicker of a civilization passing in the night. If the universe is full of short, sharp shocks, then the wow signal wasn't a fluke. It was the model. It was the streetlight turning on for 72 seconds and then burning out. So how do we change the search? If we stop listening for a polite hello, what do we listen for? We hunt for their pollution. We hunt for the debris of progress. Just as we look for the chemical signature of biological life, oxygen and methane, we can now look for the chemical signature of industry. Astronomers have proposed searching exoplanet atmospheres for chlorofluorocarbons, CFCs, or nitrogen dioxide. These are complex chemicals that do not exist in nature. On Earth, they are the result of refrigeration, propellants, and combustion. If we see CFCs in the spectrum of a distant star, nature didn't put them there, a machine did. We also look for shadows. You might remember the controversy of Tabby's star, a strange sun that dimmed erratically, losing 20% of its brightness in ways that defied planetary physics. It flickered. While the dust eventually settled on a natural explanation, the method remains sound. We are looking for massive structures, Dyson swarms, or giant solar collectors that briefly block the light of their host star. And we are entering a new era. With the next generation of wide-field telescopes, like the Vera Rubin Observatory, we will soon scan the entire southern sky every few nights. We will finally have a camera fast enough to catch the flashes, the explosions, and the brief glimmers of artificial light that vanish before a human astronomer can even blink. We are moving from taking long exposure photographs to shooting video. There is a final, unsettling realization in this theory. If we are looking for a loud, messy, accidental civilization, we need only look in the mirror. Humanity is not quiet. We like to think of ourselves as observers, but for 100 years, we have been blasting our existence into the void. Not through intentional messages, those are weak and rare. Our loudness comes from our military radar, scanning the horizon for missiles. It comes from the megawatt pulses of our planetary research, bouncing beams off asteroids. It comes from the leaked radiation of our television towers and cellular networks. We are the ones screaming into the dark. We are the ones creating the anomalies. If there is a quiet, watchful civilization out there hiding in the safety of efficiency, observing the dark forest protocol, they have probably already seen us. Not because we introduced ourselves with a plaque on a spacecraft, but because we are the streetlight in the dark parking lot. We are the flare in the night. The question isn't whether they are out there. The question is, when the next great flash lights up the sky, when the next wow signal washes over our planet, will we be looking in the right direction to see it? Or will we still be staring at the ground, looking for keys under the only light we know? If you want to keep exploring the darker side of the cosmos and the mysteries that science is just beginning to unravel, make sure you're subscribed. The universe is a big place, and we're just getting started.